Okay, let me get started. Good morning, good afternoon. I'm Ryan Chi, glad to be here today talking about the scaling ADAS simulations on AWS with one of our close partners, IPG Automotive. You can see Pravashi and Dave on the screen. Welcome to join our event. Dave, you can go to the next slide on the agenda. So in this session, we'll be talking about the common challenges our customers are facing when it comes to ADAS simulation scaling. And also we'll be presenting a solution we jointly built by running the widely adopted ADAS simulator called IPG CarMaker on top of a newly launched AWS Batch multi-container jobs feature. And towards the end of the presentation, Dave and Pravashi will walk you through a lab demo and showcase how an IPG CarMaker user can quickly deploy a large number of simulation scenarios on AWS. Next slide, please. Okay, let's talk a little bit more about why running simulation at scale is critical for ADAS development. So there is an interesting study, as you can see in the middle in the table. It's conducted by the R&D Corporation. It's basically telling us for autonomous vehicles, if we need to demonstrate it can be like 95% confidence that autonomous vehicle is 20% better than the average human driver, these are the amount of miles and years the autonomous vehicle need to drive. For example, if you just look at the last row, right? Human drivers in general, they are causing about 1.09 fatalities for every 100 million miles of driving. To beat this benchmark by 20%, autonomous vehicle will need to drive 11 billion miles, right? So if you assume, there is a fleet of 100 vehicles running 24/7, it's going to run like 500 years. So basically, it's unrealistic for us to run all the real-world simulation, to run all the real-world testing, but we have to use some sort of virtual testing or simulation to partially replace and accelerate the real-world testing. Secondly, for the ADAS simulation, they are super complicated. We are talking about perceptions, where you have the algorithm take the data from a bunch of sensors, like cameras, LiDAR, radar. And we have the prediction piece, where the vehicle's behavior depends on the agent's behavior. By agents, basically, we're talking about pedestrians, other cars, weather condition, road condition, traffic condition, everything around the car, right? So our customers are telling us, usually they need to simulate millions of scenarios to have a pretty good coverage of all the corner cases. That's the scale we are talking about. Next slide, please. At AWS, we are working backwards from the customer needs, and we have been releasing several services and solutions to help customers scale their simulations on cloud. So when we are talking about scaling, usually we are talking about in two dimensions. One is about scaling up, the other is scaling out. By scaling up, basically we are giving you more and more computing power, both on CPUs and GPUs, so that you can have a single simulation to do more than before and run much faster than before. By scaling out, basically we are providing you the capabilities to run a lot of smaller simulations over and over again under different scenarios and conditions. And most importantly, majority of the scenarios can be running in parallel. So they significantly accelerate your development time and also time to market. Next slide. Now I'm going to spend a little bit of time talking about AWS Batch because this is one of the services we released that can help customers to scale out their simulation need. So basically, Batch will allow developers and engineers to effectively run like hundreds of thousands of containerized batch processing, such as machine learning model training, like simulations or analytics computing jobs, while they are still optimizing your computing resources. Now it's going to free up your focus to do more work analyzing the results, solve the problem, instead of worrying too much about managing the infrastructure. So essentially, Batch are two things. One is an advanced scheduler, and it's also advanced orchestrator. As a scheduler, basically it takes the volume and the resource requirement for each job, build the job queue, and optimize the job distribution based on your scheduling policy. As an orchestrator, Batch can automatically scale up and down your compute resources with a fully managed infrastructure that support the large-scale simulation across services like ECS, Fargate, and EKS. If you go to the next slide. So many customers are using Batch to scale their simulations. In automotive industry, for example, you can see some familiar names here. One example, in the Continental and AWS, we are collaborating on developing a framework. It's called Continental Automotive Edge Framework. This is a modularized framework for the like software and hardware development. One of the use cases, of course, is for ADAS validation. So as you can see here, Batch was able to reduce their simulation time from 3 weeks to 4 hours. Another example is with Toyota Research Institute, where they were using Batch to train their AI/ML models for their high-precision map development. And Batch was able to reduce their training time by 75%. I'm going to talk a little bit more about the details on the Mobileye use case in the next slide. David, if you can jump over to the next one. Yeah, thanks. If you are familiar with Mobileye, they are an ADAS technology company. If you look at their cars, they have like 12 cameras and a bunch of other sensors around a single car. As you can imagine, for a fleet of like 10 vehicles, right, they can easily generate hundreds of petabytes of data every year. So a single process, traditionally in their data center, will take them several weeks to months to finish. With Batch, we are able to concurrently and automatically scale up, use 500,000 CPUs, and then complete their simulation in a few hours. More importantly, the compute environment Mobileye was using was actually the EC2 Spot instances. As you may know, Spot instances are much cost-effective compared to on-demand. And also thanks to the robust the retry feature of Batch, customers don't worry too much about the interruptions by the Spot instances. So overall, we are saving about 90% of the cost compared to the on-demand instances. If you go to the next one. Now, as we are getting deeper into the ADAS simulation, another challenge we saw was about the limit of number of containers we can run per job. So traditionally, our batch customer, they can only run a single container per job. That means for a complex system like ADAS, you have to build everything like 3D environment, your sensor data, vehicle dynamics, your autonomy stack, everything into a single, extremely large and monolithic container. So the downsides are pretty obvious, right? One is time consuming. Every time you make modifications to the container, when you're uploading and downloading, it's taking a lot of time. Secondly, if you see some failure in the simulation, it's a little bit hard to debug because everything is kind of tangled in the same container. It's hard to find the root cause of the failure. And then thirdly, for a large system like ADAS, you need many teams to collaborate, right? If you only have a single container, it's hard to divide the work across different teams. So if you go to the next slide, Dave. As of 2 months ago, so AWS has launched a new feature. It's called multi-container jobs feature for AWS Batch. Now, with this new feature, our customers can run up to 10 separate containers per job. This makes it much easier for our customers to still benefit from the scaling, the scheduling, cost optimization with the batch without the need of building a single large container. Now they can separate their simulation into different containers, such as we have one container for 3D environment, we have one container for the heavy simulator, we have another container for the autonomy stack, and so on, right? This can greatly speed up the job preparation and also the debugging process for our customers. Now you can easily find the root cause and identify any failures across all the components. With that, I'm going to hand it over to Dave and Parvashi to talk about the integration between IPG CarMaker and AWS Batch, and also provide you a demo. Thanks.
Thanks, Ryan. As Ryan mentioned, my name is David Howarth, and I'm the Director of Business Development at IPG, and I'm located in the US. I have a handful of slides here. The first is to start off with a little bit of background on IPG Automotive. Who are we? So we were founded about 40 years ago in Germany, and that's where our headquarters is. And our earliest products were simulators with an emphasis on vehicle dynamics. And over time, we really started adding a lot more capabilities for things like powertrains and full vehicle simulation. In the last 10 or 15 years, we've invested a lot in terms of ADAS development and autonomous driving support. So today we have about 400 employees globally, and we have offices all over the world in all the main cities and countries that are involved in automotive. A little bit about us here too, in terms of our focus and our specialty, you can think of in terms of virtual test driving. So if you think in terms of physical test driving, where you would take a prototype physical vehicle and do test drives on the road, the concept is you would do that in simulation instead. So a customer typically will build a virtual vehicle prototype that can match very, very similarly to a physical prototype. So all the vehicle dynamics, the behavior of the powertrain. So for instance, if you're doing electric vehicle development, you can build your electric vehicle, your electric motor and battery, so it'll match up. So some customers do things like battery range estimation, things along those lines in CarMaker. And we're one of the leading suppliers in the world for this type of capability. And we're really happy to be partnering with AWS to bring that capability to the cloud. So a little bit about how that works. So a lot of our users do feature development with CarMaker. So you can think in terms of model-based development. Model-based development is typically controls-based, doing controls engineering with a product like Simulink to build an ADAS feature. And that could be an AEB or an ACC, but that's using a control as a starting point. Also, if you're doing machine learning or object-oriented development. So it doesn't really matter what approach you're taking to build your feature. You can use CarMaker in terms of being able to integrate that software into your virtual vehicle to test that software, test that capability in a virtualized vehicle that's running through an environment. A lot of customers want to then take that feature and do a lot more validation work, including variants. So you can take a scenario that you made, or you can take a virtual vehicle prototype that you made and start making slight changes or slight variants to that and scaling that out to run a lot more scenarios. Another type of use case that we get used quite a bit in are in lab-based. So in this particular example, that's what's called a steering hill system. And what this customer would do is they would take their steering system, so all the mechanical aspects of the steering system and the electrical and the electronics that control that in the software, put that in a lab. But they only have to have that part in the lab. They can have the whole rest of the vehicle virtualized in CarMaker. So they can run with whatever powertrain they are. They can do test drives on virtualized roads, and they can calibrate and test out their steering system in a lab. Also, a lot of use cases in terms of full simulators, driving simulators, vehicle in the loop. If you're not familiar with vehicle in the loop, this is a really powerful technology where you can take a physical vehicle, bypass all the sensors, and instead run something in CarMaker, run a scenario in CarMaker, and have all the sensors, camera, radar, LiDAR, input from the simulation environment. The reason that's helpful is you can take your physical vehicle out to, say, a big parking lot that's totally empty, but have scenarios playing with traffic objects and pedestrians and test drive your vehicle in a virtualized environment, but in a real vehicle on a real surface. Just a little video here showing some of the capability. So this is downtown San Francisco, but again, remember, you would make your ego vehicle really match up in vehicle dynamics and all the other aspects that you need to what your physical vehicle could be. And then you set up your scenarios and your roads and your traffic objects and pedestrians and things and run those in a simulated environment. Okay, so what does that mean in terms of running with AWS Batch? That's really the focus today. So one possible use case, and there's many, but one that we'll use for the example for the moment is, let's say you're an automotive engineer, you're a development engineer, and you're developing an ADAS feature, or you're doing autonomous driving development. And you're using some kind of an autonomy software stack to do that. So the challenge you run into is to do this type of development, even with traditional ADAS, the requirements are constantly increasing, and the coverage that's needed is also constantly increasing. So you need to run a lot more scenarios than you did some number of years ago. Many developers who are doing especially ADAS typically develop on their local PC, but that's not really adequate if you want to run a lot more scenarios. You can do a handful of scenarios, that's no big deal, but if you want to start doing thousands or hundreds of thousands of scenarios at a time, you really need to find a way to offload that up onto the cloud. But the other challenge is for users, for those development engineers, actually scaling up onto the cloud also remains another big challenge. So the solution that we see is really making CarMaker run very efficiently and simply with something like AWS Batch in order to scale that out. Okay, a little bit about what's that mean, multi-container support for ADAS and AD with CarMaker. So why would you want to do that? Well, having multiple containers enables a user to have a really clear and clean separation between the test environment and the system under test. And Ryan talked a little bit about this earlier. So you can think of what you can do is you can put the CarMaker environment in one container, and then your your software stack into another. And we've been working on a new reference design to take advantage of the multi-container support in Batch. So it's going to be ready here fairly soon. But in the first container, it's CarMaker, and in the second, for this example, we're using ROS. And if you're familiar with ROS, or if you're not familiar with ROS, ROS is the robot operating system. It's used by a lot of companies and a lot of researchers to do autonomy-based development. And there's a lot of libraries and examples and know-how and capabilities and standardization around sensors. So there's a lot of really good aspects that people take advantage of. So folks will work on their autonomy stack in ROS, but they need that to connect up to CarMaker. So with this new reference design, we'll show how to do that in multiple containers. Now, you don't have to use ROS. You can use any type of technology you want, but for this example in this reference design, we did it with ROS. So how's CarMaker itself run up on the cloud, run up on AWS? So when you run CarMaker on a desktop, you have a lot of additional tools that come along with it, and also a full GUI for interacting with the system. So it's really designed for an engineer working at their desktop to do all their work. So the nice thing, though, is when you go to run that up on the AWS cloud, you can run a headless version where all the GUIs and these other things you don't need aren't included. And that headless version, that executable, is the same executable from the full GUI version. It just can run standalone and headless. So it makes it really easy to containerize and then to scale out. Also, the CarMaker executable is single core and single threaded, so it's fairly simple to control. One thing you have to keep in mind, though, is one CarMaker instance will run one scenario at a time, right? So if you want to do a scale out, as Ryan had mentioned, and do these in parallel, you'll need more than one CarMaker instance. So a couple examples. If you're only going to run, say, 10 scenarios, and they're pretty quick, it's not that big a deal. You can probably do that on your desktop. But if you need to run, say, 100,000, well, now you might say, okay, let's set up 100 CarMakers all running in parallel, separate instances all running in parallel. Each of those instances would then run 1,000 of these test scenarios. Or you could have 1,000 CarMaker instances all set up in parallel, and each one would run 100. So there's trade-offs in making those decisions, but the key there is how fast do you want to get all of those run? Do you want something very quick that you can sit there and wait for a minute or so and get them all back, or are you going to run it overnight? The good part is AWS Batch can run multiple CarMaker batch jobs in parallel. You can do that for a single user or multiple users. Architectural diagram, don't have to go through everything here, but basically just want to get across. Here we have the two containers. The left one is the one I mentioned before, CarMaker, which includes a ROS bridge, and then the autonomy stack running in ROS in a separate container. And then those can talk to each other via ROS messages between the two containers. If you look over to the right, on the far right side, you'll see an S3 bucket. So the way this reference design is set up, the test scenarios themselves are stored in a S3 bucket, and then the result files that come out of each of these test runs are also put into an S3 bucket. And both these containers will run on a single host, a single instance, running using EC2 instances, but you would have as many of these as you need in parallel to finish a job as quickly as you need. Okay, Pravarshi is going to do the demo.
Yeah. So hi guys, my name is Pravarshi. I'm an application engineer in IPG Automotive USA. So I'll just show you what Dave has explained of the multi-container setup, and I'll show you how a user can basically run simulations on the cloud. So let me know if you can see my screen. So here what we did is we have created a custom interface so that people who are not familiar with CarMaker also can basically use it to generate variations of a test run and run it on a cloud. So basically when you go here, you can go to generate scenarios page. So what that means is, suppose say you have one test run and you want to create multiple variations of the test run and you want to run it on the cloud, you can just create that variations on this page. So basically you can just give the values of the variation. Say in this case, I want to control the velocity of the starting velocity of the ego vehicle. Like I want the ego vehicle to start at 10 in one variation, 20 in other, 30 in other. So if you want that, you can just create that here. You can just give the step values and generate scenarios and then copy those scenarios, and those scenarios are generated here. So you have 4 different variations. And now if you want to run these on the AWS, then the simply user has to just go here and you just have a page of AWS Batch job configuration. So here you can specify which bucket you want to place those variations in, what job queue, give the custom name for your job, what job definition you want to use, what the array size has to be. Like say I want like 5 different arrays to run, and then you can select the folder in which the variations have been created so that you can upload them to the S3 bucket, and then you can submit the job. So basically you can go there, copy the path of your folder and just replace it with the default path, and then save configuration, copy files to S3 bucket, and you see they're copied. So if you go here, yeah, so you copied the files here. So basically whatever files you have on the local, you can just do that with one simple click, and then you can just go to the home page and then just submit the jobs. So basically this will just submit the jobs of your specified job queue. And if you see here, it's pending. So we have submitted the jobs. So basically now we have the multi-container setup. So one container is running CarMaker with those variations you have selected. Other container has the ROS running on it, ROS 2 in this case, but CarMaker supports both ROS 1 and ROS 2. Again, it's the variations of ROS. We cannot get into the details, but yeah. And what happens here is the ROS basically is sending signals like a controller basically of different brake values for the CarMaker vehicle. So the CarMaker vehicle just receives those brake values and just it applies those so that you can test your, say, the braking distance. Say you have a automatic emergency braking controller you want to validate or you want to test, you can just use that in this case. And to visually show you what is going on, I can just run the simulations here quickly. So these are the variations. If you see, this is how the CarMaker GUI looks. So basically the variations I've created from the custom interface are these. And once you start them, you can just go here. So we have this tool called Movie NX. It's a visualizing tool. So you can just see how it looks. Basically here, what's happening is the ego vehicle just uh, avoids the pylons, and we have created a criteria, like say if it hits a pylon cone, then that's a failed criteria. So just for an example's sake, so if in your case you have something like a pedestrian is crossing and you have to apply the emergency brake within certain distance, you can have that as a pass fail criteria. So you can apply that in this CarMaker scenario. So
Yeah, one thing, just to interject real quick. Yeah, so basically the demo here is showing the different variants. So the vehicle, the ego vehicle is going at different speeds through these different variants. One of the key things we found talking to different customers doing level 3 controls is one of the biggest challenges they've had is with vehicle dynamics, right? With curves, running on curves, or any kind of dynamics that the vehicle might experience. So one of the things that we found is if they use a physics-based approach to trying to test their system out, like we're seeing here, you can see issues very quickly that if they didn't use something like CarMaker with a virtual vehicle that would behave like an actual vehicle, you would miss those things, right? Things could still work from your software perspective in a idealized environment, but when you bring it into something with a real vehicle, it would fail.
So as you can see, I am manually setting the steering value here. So basically that would be the ROS in the cloud. So ROS will actually set the value of say 0.9. When you saw the vehicle just move away, I can show you again if you want. So basically that is what the ROS does, and you can see the vehicle leaves the road. So you can have that as a criteria, like you can just set and see the vehicle goes off. So you can just say the scenario failed. So something similar is happening on the cloud. So just for the visual sake. And if you see, the jobs are still running, but once the jobs are run, you can go to the results page. So basically we have containerized and created a script where the CarMaker runs the simulations of all the variations, and then the results are stored here. And then you can just post-process those results. You can just download them if you want to your local system, or you can have an HTML code in the container itself where it can process these results, and whatever criteria you want to validate, you can just have a graphs of those to just analyze the data and stuff. So yeah, that's pretty much it. So it's basically it makes it user friendly. Like if you're not familiar with CarMaker, also this interface can be actually customized and used. So
Parash, if you go back to the slides, we have one more just on the call to actions. Basically, if you are an existing CarMaker user and you want to learn more about the scaling and the batch integration, you can either talk to David or myself. Welcome for the conversation. Second, if you are new to IPG CarMaker, you want to explore more about the capabilities, please contact David. Thirdly, if you are just in general interested in scaling ADAS simulations or robotic simulations on the cloud, please reach out to me. So Lauren, we'll back to you if there's any questions from the audience.
Yeah, thank you so much, David, Ryan, and Pravarshi. Really, really insightful look into how you're enhancing efficiency here. So for the attendees on the call, if there are questions, feel free to use the raise hand feature or drop a question in the Q&A box, and we can go from there. I think we have a couple minutes here for a Q&A. If no questions for the moment, I do have a question for you, Ryan. You talked about batch multi-container jobs and it looks like a great feature. Can you share a little bit more about how this feature works with other AWS services?
Yeah, so the multi-container feature is available on Batch for the services like ECS, Fargate, and EKS. These are different compute environments, right? So especially for customers who are already using ECS, Fargate, or EKS, they are already using multi-container feature in those environments. It's much easier for customer to just use it in Batch. You can use either through Batch Management Console or API, or if you have your own application, you can just connect to the SDK, or you're using the CLI interface. So this will allow the customers to basically use their most familiar and best suitable use cases, and for the and also align with their past experiences. Also, one thing I want to point out is across ECS, Fargate, and EKS, you may see some differences. For example, in terms of the container sequencing, like the sharing namespaces, and when you set up the essential containers, you may see some difference. For example, to set up essential container, you don't see, you can just go through ECS and Fargate, they are supported. But when you're using EKS, because Kubernetes itself doesn't support setting up essential containers, so this feature doesn't exist in the EKS. Hope that makes sense, Laura.
Great. Yes, thank you so much. Any other questions from the audience? Okay, if not, I'd like to thank you all so much for the presentation. For the attendees, please do leverage the survey. There's a QR code on the screen. Submit at the end of the event. It would be greatly appreciated.